Hi guys, welcome to this page of the notes, and again we're working on hyperbola where we give you some information about it, graph the information to get yourself the equation for the hyperbola, and now for the second time in a row we see we're given asymptotes. But just like last time, hopefully you can quickly recognize they're in slope-intercept form. Y equals mx plus b. In this case, b is 0, so you run right through the origin right there. The slope is 7/9, that's up 7 over 9. This one's negative 7/9, so down 7 and over 9. Let's start by graphing those asymptotes. All right, so I'm going to go through 0. That's my y-intercept. My first one is up 7 and over 9. Up 7 over 9. I could also go down 7 and back 9. That's the same thing. My next one is minus 7/9. So that would be down 7 and over 9. Puts me right over here. But that's exactly the same as going positive 7 and minus 9. So positive 7 minus 9. And just like that, guys, you've got your rectangles, right? Those points represent the corners of your rectangles. You should be comfortable with that from the last problem, but even if you're like, really, I don't understand how you're getting that so quickly, take a look at your formula sheet, right? I've given you the vertices, which means that this is my transverse axis, which is horizontal. So I am centered at the origin. I'm horizontal, which means it is x squared over a squared minus y squared over b squared is equal to 1. But more importantly than that, centered at the origin, horizontal transverse axis means that the asymptotes, look at your formula sheet, right off the formula sheet, the asymptotes are at y equals plus or minus b over a x. Well, we saw this the last time. That's my B. That's my A. My vertices only confirm it, right? We know the vertice is A, the distance from the center to the vertice, which is 9. And there it is. There's my 9, right? So, again, hopefully this stuff is just kind of jumping out at it. Yeah, it should be at this point. So that's how I knew that that's my box. I draw my asymptotes through the box. Goes through the corners of the box. My hyperbola has to go through the vertices without touching the asymptotes. And again, this one doesn't really fit quite so well, but it's going to look something like that. My graph's not quite big enough. But you kind of get the idea. It'll look something like that. And I know A and B, right? I know what A and B are, so just drop them in there and we'll be done. A is 9. 9 squared is 81. B is 7. B squared is 49. It's all equal to 1. And cuckoo, cuckoo, you got yourself your equation for the hyperbola, and we even went ahead and graphed it. All right, guys, at this point, you should be very, very comfortable with hyperbola. No matter what information I give you about the hyperbola, drop it on a graph, go ahead and graph that hyperbola, and then from that, use the formula sheet to figure out which formula you need, plug in the information that's got to go in there. You'll need A and B, but all that will come right from your graph, and you'll be all set. Head on over to the next page of notes and we'll go the opposite direction. Instead of me giving you some information and asking you for the equation, I'll give you the equation and you'll graph it and then give me the stuff I ask you for. Really excited to try these ones with you, so head on over to the next page of the notes. I'll meet you guys there.